Hi, good morning everyone. Today we're gonna discuss about the topic name called remote monitoring on environmental quality using IoT. Yeah, now, coming to the introduction, it is mainly about further industrial organizations and the pollutions which were displaying in our present sectors. So, in the modern times, the society is heavily influenced by the environmental pollution. For this sake of reason, the intelligent system has developed with very high efficient, low cost, low power consumption to qualify these particular parameters. So, if any one of the gases or water quantities are releasing from the particular organization, we will be detecting each of the gases which was released by up to the specific mark. If any one of the specific mark has crossed, then we are gonna sending an SMS alert using an email and a message, and we also gonna displaying in the LCD display as well. With addition to this, the data which was censored will also upload to the cloud server using a GPRS modem. It will detect all the harmful gases and the water quality parameters. So this was what the introduction was. Coming to the next slide, we will be gonna explaining about the existing system. In the existing system, the present is pollution is a major issue in the society. So many of the organization releases the harmful gases in the air like CO2, CO, nitroxide, monoxide, and all of these etc gases. These are very dangerous to our public health. So to prevent this particular, government has planned and established the pollution control board to control the gases released by the organization. But due to lack of automated gas level monitoring, controlling authority is not reaching up to the mark. Now, what we have proposed was, if any one of the air pollutant gases crosses the limit of the specific gas, then the email or SMS alert will be sending to the person who monitors the pollution of an industry and the authorized person who controls over the polluting industries. And addition to this, if any device disconnect from the cloud, then if any power system fails, or else if any network disconnects or device damages, the email and SMS will be sent from the cloud to the person who monitors the pollution of an industry and the authorized person who controls over all the polluting industries. Now coming to the block diagram, this was what actual Arduino Uno we are be using, and we are connecting each of the sensors to the particular Arduino Uno and supplying a power supply to the Arduino Uno, and we are gonna having a Wi-Fi GSM modem and a LCD to display each of the results and sends the data and happening via internet. Mm, Now, coming to the hardware and software requirements, we are having the hardware components like MQ9 sensor, air quality sensor, DHT11 sensor, pH sensor, Arduino Uno, Wi-Fi module, GPRS, and LCD. These are the hardware components we are gonna be using, and software components like embedded C, which I have written the embedded C code to detect all this and to execute, and I have used a cloud named ThingSpeak, which is a web application interface. Yeah, now coming to the brief explanation of all the components. Firstly, we'll be talking about the Arduino Uno. Arduino Uno is one of the open source electronic platform, and it is very easy to use for both hardware and software. And Arduino boards can read both the input lights of a sensor and which each finger of a button or Twitter message and turn it as an easy single output. And Arduino boards are relatively inexpensive when compared to other microcontroller platforms. As we have seen in the diagram, we will be having looking as a Arduino like this, and we will be having the reset button, USB port, power connections, analog and digital pins, power LED, microcontrollers as well. Now coming to the MQ9 sensor, the MQ9 sensor will detect all the carbon monoxides and dioxide gases, and each of the gases will be detected by a method with very high and low temperature, with very, and the voltage of each of the temperature will be 1.5 volts according to the gases which has been detected. And the sensor connectivity is higher along with compared to other gas concentrator rising. Now coming to the pH sensor is mostly used for checking the water quantity parameters with the alkalinity, and the range value should be between the 0 to 14. And if any number above the 7 equals to more alkane, each type of pH sensor works differently to measure the quality of the water based upon the range which was detected in the water. Now coming to the DHT11 sensor, as we all know, the humidity is the main important where we can able to calculate all of the sensor data. The DHT11 sensor will be mostly used for that with very low cost digital temperature, and it is also used as a captive humidity sensor with thermistor to measure the surroundings of air and spits out one digital signal of the data pin. Now each of the element is strictly calibrated in the laboratory that is extremely accurate with the humidity calibration. Now coming to the LCD display is also known as liquid crystal where we are gonna be displaying the results in the LCD screen, and it is an electronic modulated optical device that will be most used for light modulating properties within crystal polarizers. Now coming to the GPRS model, GPRS model is nothing but also known as GSM, which is briefly explained as Global System for Mobile Communication, which is mostly used for digital mobile telephone system that is widely used in Europe and other in the world as well. And it also supports a voice call for data transfer speeds of up to 9.6 kilobytes together with the transmission of very short message service. This was what the GPS modem, and it always be censored for every 1 second of the data which was been censored and using with the sensors. A Wi-Fi connector. As we also know, the Wi-Fi connector we call the Node MCU. It is one of the open source firmware development kit that help us to build and prototype the each of the IoT project using this Wi-Fi ESP8266 module. And it also includes a firmware which runs on the ESP Y2 SoC for each of the hardware module on the ESP12 module. So now coming to the system functions, we will be having the functional requirements and non-functional requirements. As we know, functional requirements consist of data tracking, data sender and messaging sender, and the sensor data sender. And data tracking is nothing but of sensing the each of the sensors with very each value by releasing from a particular industry. Data sender, who is nothing but of an hardware, must having a GPRS module to fetch each of the data, and message service is nothing but of receiving the data from the GSM module and showing the display of each of the alert messages to the person if any emergency happened. And user can also monitor the sensor data through our web interface application named called Web API ThingSpeak Cloud. And coming to the non-functional requirements are not directly related to the functional behavior of the system. The web application must be either user-friendly, simple, and interactive, but the user interface designed in such a way that voice user with little knowledge should also can be able to access this particular application. So this was what the non-functional requirements. Now coming to the UML diagrams, we will be having the class diagram and the sequence diagram. Now we're gonna displaying about class diagram. A class diagram models the static structure of a system which shows the relationship between our classes, objects, attributes, and the operation. It will start with an attribute called start, which each of the function will be sensing from the input sensor, which will read the data. Once it read, it will be parallelly executing in the LCD display and sending to the cloud as well. So once it will censored in the LCD, it will be displaying from the sensor, and once it go to the cloud storage, it will connect, store the data and process. It will be happen all to the GSM, which can read message and write message and able to view the SMS or the email alert. Now coming to the sequence diagram, as our name suggests, the sequence diagram describes the sequence of message interactions that happen between the actors and the objects. The actors will be having person, sensors, LCD, GSM and the cloud, where we will be performing the objects like performing the actions first to the request, and each of the request is sensing the gases. Once the data is been sensed, it will be displayed in the screen and parallelly storing the values in the cloud. A user can observe the values, and if any data crosses between or disconnect happen, SMS will be sent to the person and person can able to view that SMS or an email. This was what the sequence diagram explained. Now coming to the advantages, it is most reliable with most security, and it also contains of low density with more portability and easy to handle. Sensors have long life and also a less cost, detecting a wide range of physical parameters including temperature, humidity, carbon dioxide, water and air monitoring as well. These are the main advantages for these quantities. Now Now coming to the result, this was what the actual circuit diagram look like, and the middle one is the Arduinos, and from the left panel we will be having all the gas sensors and the water quality sensors connecting to the analog pins, and in the right side we will be having the LCD Wi-Fi module and the GSM module which will be connected to the digital pins. Each of the pins will be selected and each of the connections will be placed according to the circuit diagram. Now this was what the actual kit connections, and we have connected according to our circuit diagram, and this was what actually looked like each of the sensors and detecting and displaying in the LCD as well. Yeah, thank you.